Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I want to give you a code review on what I did with this Kaggle competition, U.S. patent phrase-to-phrase matching. And so you can win $25,000 prize money, but the thing about Kaggle is you have to be in the United States to actually collect the prize money. So I'm not sure if you can just fly to the United States to collect the prize money or if you have to actually be living in the United States. But you could win $25,000 if you score the best. So I'm going to give you a code review, but before I give you the code review, I'm going to go over all of my different attempts to solve this conundrum. And all of my attempts to solve the conundrum, I'll tell you what I did, and then I'll pick out the best score, and the best score will do a code review for that. So I did a patent phrase similarity trying to use sklearn's TF-IDF. I only got a public score of 0.3759. I tried to use it in LTK, and the computer wouldn't even accept it. It went into error, and I thought, well, I don't know what's happened, and I'm not going to try to find out what happened. It worked okay when I ran it on Kaggle, and it worked okay when I saved it on Kaggle, but when I submitted my results to Kaggle, it went into error, and I thought, I'm not even going to try this. Now, in this particular one, I tried to do it like as a prediction. So what I did was I used random forest algorithm to make a prediction on it. And that was probably the second best score, but it wasn't the best score. The next one, I used decision trees, and that wasn't a very good score. You can see that that wasn't a very good score. The next one, I used something called sequence matcher, and the score was better, but it wasn't the best. The next one, I tried to use cosine similarity, and it wasn't a very good score. And the very last one was I used Spacey, and I got the best score using Spacey. So Spacey is going to be the Jupyter notebook that I'm going to do a code review on. And you can see I've got 49 views already, so people have been looking at my code. So what we'll do is we'll go ahead and go over the code review for the Jupyter notebook where I got the highest accuracy, which still wasn't even 50%, but it was enough to get me on the leaderboard. So since it was enough to get me on the leaderboard, you know, you get on the leaderboard, and then what you do is you keep working to try to improve your score, which is what I've done. In the last 24 hours, what I've been doing is working to try to improve my score, and obviously my score didn't improve. I couldn't get it to improve. I mean, you have to be a really good programmer to enter these competitions, and you know, I'm trying, I'm doing my best, and I'm trying, but you have to be really super, you know, and obviously I'm not really super, but you know, at least I can get on the leaderboard, and I can tell you what I did to get on the leaderboard, even though I'm not submitting winning predictions. And the thing is that people who win these competitions, they're not going to give you their code. And then quite often their code is a mismatch of things to try to get it to work. But I did mine in a very logical format, even though I'm not a winner. So we will look at the problem statement. In this data set, you are presented pairs of phrases, an anchor and a target phrase, and asked to rate how similar they are on a scale from 0, not at all similar, to 1, identical meaning. So that's the problem statement. That's what we've got to do. So the first thing I did was I imported the libraries. I imported NumPy, which is for numerical calculations and NumPy arrays. I imported Pandas, which is to create data frames. I imported Matplotlib, which is a graphics library, and also imported Seaborn, which is another graphics library written on a higher level than Matplotlib. I also imported OS, which is the operating system, and what that does is that goes into the operating system and it retrieves the files. So you can see that I used it to retrieve files, and you can see that it retrieved 3 files: train, test, and sample submission. I used Pandas to read these data files, and then what I did is when I read the data sets, I defined them as train, test, and submission. So here's your train. It's got 36,473 rows of data, which is good news. And the reason why it is good news is because the more data you have, the harder it's going to take. One thing I've noticed about this score is it's done in quartiles. So that's interesting. I hadn't noticed that before, but it is done in quartiles. But one of the scores that I had was actually done in quartiles as well. And it was done in quartiles as well, and but I didn't get a good accuracy. I only got an accuracy of like maybe 300%. So I could like try to do this in quartiles and see if I can get a better score, because I just used a regressor for that. But there's a possibility that you could have used a classifier. And so like 0 is 0, 25 is 1, 50 is 2, 75 is 3, 100 is 4. And so you would have like 4 categories. So there's a possibility that you could do that, and I might just give it a try. And then when you do the 4 categories, like a 0 is 0, 1 is 25%, 2 is 50%, 3 is 75%, and 4 is 100%. So that's really interesting there, because it's not really, it could be categories. You could convert the categories to numbers if you wanted to. You could, once you get your categories, you can replace the categories with numbers. So that's interesting. It might even help improve the score. And then you have your test, which is only 36 rows of data. And then you've got your submission, which is only 36 rows of data. So now what we're going to do is we're going to analyze the score, and you can see the analysis that it's 0, 25%, 50%, 75%, and 100%. So that's really categorical, even though it doesn't look categorical. So there's a possibility I can go through and try to make it categorical and see if that improves the score. Now we do a box plot. So this is your box plot. It shows you the first quartile, the second quartile, the third quartile, and the fourth quartile, and then you've got an outlier over there at 1. So here's your box plot. Now we're going to define the target. The target is going to be the score. Now we're going to combine the train and the test to make it one large data frame. Call it combi. We're going to define our x and y values. Your y is your target, your x is your combi up to the length of train, and your x test is your combi from the length of train to the end. Now we're going to use Spacey. Okay. So we install Spacey, and then after we install Spacey, then what we're going to do is we're going to download the English version of Spacey. And then after we've downloaded the English version of Spacey, we insert our code. So you import Spacey, NLP equals Spacey.load, and then in core web LG similarity is blank list for I and range length of X test. Anchor equals NLP X test anchor I. X test target equals NLP X test target I. Sim equals anchor similarity test target similarity dot append sim. And then I said print len similarity and print similarity. So what I might do is just take out the similarity so it doesn't. Now what we're going to do is we're going to prepare our submission. Submission score equals similarity. Submission to CSV equals submission.csv. Index equals false. And then you've got submission. And that's it. That's it for the code review. And I think what I'm going to do is I'm going to go back and try to do the code review and try to make it in the quartiles, so 0, 0.25, 0.50, 0.75, and 100, and see if that improves my accuracy, because what we have to do is we're always striving to improve the accuracy. But so I think I'm going to conclude this code review because I've got more work to do. But I want to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. Thank you so much for watching this video, and I look forward to making more videos for you in the future.